Hi everyone. All right, this is take 2. All right. So yesterday we were talking about ways that we can store information to improve our short-term memory, and try to help store information long-term. So I believe in most classes we got through chunking and we got through rehearsal. So I'm going to start today talking about levels of processing. So if at this point you don't have your pink notes out, it would be a really good idea to get those out right now. All right, so levels of processing. Here's what we mean by that. There are 3 different levels of processing. There's shallow processing, there's intermediate processing, and there's deep level processing. All right. Now, when we're talking about levels of processing, we're talking about ways in which we think about the information that we're trying to remember. Okay. So, for example, let's take the word mom. Okay. If we were going to process the word mom on a shallow level, we would just look at the letters. Okay, we would realize that this is an M and that this is an O and this is an M. Okay, now at an intermediate level of processing, we would take this word or these letters, I'm sorry, and we would put it all together and we would realize that this is the word mom. Okay, and that's an intermediate level of processing. Okay. But if we were to process information deeply, we would add some sort of meaning to this word. Not only would we know that this is the word mom when you put an M, an O, and an M together, but we also know what a mom means. It means somebody that cares for us, somebody that's biologically related to us, okay? And if we really wanted to deepen our levels of processing, we could think about our own mother. Okay? You like that program? Here, hold on. My audience likes that. Say hi. Very good. Okay. All right. So this is what I mean by levels of processing. Okay? It's not just enough when you're sitting in a classroom to just see the words that are up on the board. Okay, or to recognize that there are actually words up on the board. But what we need to do is we need to process things deeply. Okay, we need to think about what the meaning of these things are, how these things go together, because what this does is this makes multiple connections in the brain, which allows for us to take and improve that capacity of the short term and potentially create long-term memories from the situation. Okay, all right. So let's see, I want to erase this. All right, now, speaking of making meaning, deep level processing, when we want to make sure that information is stored long term, we also want to try to elaborate on it. When we elaborate on information, what we do is we think about multiple ways that the information that we're learning is connected to information that we already know.
How can you write handwritten finger with a finger?
It's a touch screen, baby.
Oh.
All right. So, let's say, for example, I used elaboration yesterday, okay? If you remember yesterday, we were talking about encoding, and I compared encoding to what? What thing that we already know? Come on, anybody? Do you remember? A filter. I said encoding is like a filter, if you remember, okay? And so I connected the concept of how the encoding process works to a filter, like an air filter or like a coffee filter. The sensory information comes in, and our sensory memory decides, buddy, our sensory memory decides if that information is important or not, and it filters out the stuff that's not important, and it sends through the stuff that is important. Okay? So I connected something that you already understood, a filter, to this new process. All right? This is what we call elaboration, and this will help us to remember information more long term. Okay? Now, one of the most potent forms of elaboration is self-referencing. And self-referencing is where we can tie the new information to ourselves or our own experiences. Okay? So, I need us to think about this for a little bit. All right? When we learn things in class, if we can tie that information to ourselves, like for example, if we're talking about the behaviorist approach, and I'm telling you that the behaviorists believe that we can explain human behavior by rewards and punishments, and I tell you a story about how I got Brogan to be potty trained by giving him a reward of a pee and a poop medal, I am tying that information to myself, helping me to better remember it. So if you can think of examples of how maybe your parents potty trained you, or how your parents reward you, or how you see punishments in your life, this will help you best to remember the information. Okay? So when we're sitting in class, we want to be trying to do this stuff. When we're learning new information, we want to try to process it on a deep level. We want to try to connect it to things that we already know. And if we can, the highest way of connecting information, highest way meaning it will stay with us long term, is if we can self-reference the information. Okay?
Better get that thing that you said out of your mind.
What thing out of my mind?
That thing.
Are you embarrassed?
Yes.
Sorry. Okay.
They should be embarrassed as well.
They're not. All right. So, anyways. All right. The last thing that I want to talk about as far as strategies go to improve short-term memory and store information long-term is mnemonic strategies. Now, you might not be familiar with this word in particular, but you've seen mnemonic strategies before, I promise you. I'm sure you've seen this one before. Roy G. Biv. Roy G. Biv is an example of a mnemonic strategy. All right? When we're talking about mnemonic strategies, we're talking about maybe acronyms that we can use, maybe simple little ways that we could say the word to help us try to remember certain topics and concepts. All right? So Roy G. Biv helps us to remember what? Wait time. Wait for it. No. Helps us to remember the colors of the rainbow. Red, orange, yellow, green, blue, indigo, and violet. Okay? Likewise, I'm sure we've seen the mnemonic strategy Holmes, which helps us to remember the Great Lakes. You can figure that one out on yourself. Okay? All right. So anytime we use mnemonic strategies, this can also help us to improve short-term memory and store information long-term. All right. So these are all the strategies that one can use. Now I need to jump back. No, discard. And I need to jump back to that slide that we were talking about when we were talking about how do we store memories. Okay? All right. Things are going to get a little bit complicated here. So we've been referring to the storage process by taking place with our short-term memories. There's a guy by the name of Alan Baddeley who said short-term memory is a very simplistic way of thinking about how we store memories. Okay? And he said we really shouldn't call this type of memory a short-term memory. We should really call it a working memory. Okay? Now, here's what Alan Baddeley means by this. Okay? He says that basically what's happening inside of our minds, okay, and if you take a look at the Atkinson-Shiffrin theory, this makes sense, okay? He says that what's happening here, okay, Not right now, buddy. What's happening here in the short-term memory is when we strategize, information is transferred into the long-term memory, all right? But take a look at the Atkinson-Shiffrin theory. We also pull long-term memories into the short-term memory, all right? And he says that basically what happens in here and why we need to call this a working memory, okay, is because this old information that we already know that we're retrieving, we're pulling it in here and we're mixing it with the new information to help create potentially new memories, okay? All right, let me show you what I mean by this, all right? Remember that scratch piece of paper that I told you guys to use? I want you to get that out right now. We're going to do a little game, okay? All right, here's how the game's going to work. I'm going to show you a bunch of letters, okay? All right, now I need you to try to memorize these letters, all right? Then I'm going to ask you to do a math problem, and then and only then do you get to write down the letters after you've completed the math problem, okay? All right, here we go. Go ahead, take a look at these letters. Okay, all right, now solve this math problem. Do not write any letters down. You're solving this math problem right now. Now, don't forget how to do like order of operations and all that kind of stuff. Like you're going to have to figure out like what's 5 times 426, and then you're going to have to divide 400 by that. Yeah, I think I'm going to need a calculator. You can get a calculator out. It's fine. I can't remember what the answer to this is, so I'm going to have to figure it out myself here right now. This should be fun.
I'm not going to do that question.
Why?
Because, Mom, it's way too hard. I don't even know multiplication or whatever we're doing. Times. I don't even know 400. 5 times whatever.
Okay, did we get an answer? Anybody have an answer? Okay, so the answer to this problem, I don't really care what the answer is. Here's what I want you to do next. I want you to tell me, what were those letters again? Do you remember? Write them down.
I'm guessing.
You're supposed to be sleeping. Okay, I'm guessing that that's been about 30 seconds. All right, go ahead. Uh-oh. Check your letters. Okay, I'd be interested to see how many of you got 7. All right, if you did get 7, you have a very good working memory. All right, if you notice what was happening here is that your working memory was remembering this information as well as being able to pull from your long-term memory, how is it that I solved this problem, and then allowed you to solve this problem while retaining the memory of those letters when I ask you to list them again, all right? This is why Alan Baddeley said we can't just call our short-term memory because there's a whole lot more stuff that's going on there that we have to be cognizant of, all right? So he said that basically what's happening inside of our working memory is you have this person right here, which he called our central executive, okay? And then inside, the central executive, okay, has sort of like two assistants. And the assistants are your visuospatial sketchpad and your phonological buffer, okay? All right, so the phonological buffer, it's sometimes in some textbooks called a phonological loop, okay? You can call it whatever it is that you want to, all right? But what happens is the phonological buffer or the phonological loop, what it does is it is able to listen to all of the sounds that we hear, all right? And what it does is it repeats the words that we hear in this like phonological storage area, okay? This is kind of like, if you want to think about this as like when your teacher says something and then you internalize it and you repeat it in your head so that you can write it down in your notes, okay? So that's that kind of voice, if you will, inside there that's remembering what the teacher said. All right, the visuospatial sketchpad, all right, this is going to store visual information from the sensory environment and spatial information from the sensory environment, okay? It's going to hold that information. It's limited, of course, but it's going to be able to work with any type of visual and any type of spatial information. So this is like why we're able to remember the words on a page as we're reading them to be able to put sentences together. Otherwise, we would read the beginning of the sentence and we'd get to the end of the sentence and we wouldn't remember what's at the beginning of the sentence. Our visuospatial sketchpad allows us to be able to remember what we see and where we see it in space. All right, so that we're able to put all that together and to create that kind of a sentence. Okay? All right, so that central executive, what he does, or she does, I guess, whatever that voice is that's inside of there, it listens to the phonological buffer, it helps to work with the visuospatial sketchpad, and it pulls information from the long-term memory into that short-term memory, all right, where it can all be worked with together to be able to, I don't know, maybe solve a math problem while you're trying to remember multiple letters at a time. Does that make sense? Okay, so that's the concept of our working memories. Okay? All right, so Natalie is very well regarded psychologist for proposing this theory of the working memory. Now, this theory is so popular that actually most people have added to the Atkinson-Shiffrin theory and have removed in some textbooks the concept of short-term memory altogether and only refer to this stage of storage as working memory. So just be very aware of that, okay? All right, so this leads us to imagery, okay, which I guess I feel like I should go through just in case because I can't remember how many classes I went through, so I apologize if I didn't go through it or if I did already go through it in some classes. But imagery is where we add information, and you can stop if you want to, if you've already done this one, and fast forward through this part. This is where we add visuals, like pictures. We use visualization to remember information better, okay? Here's what I mean by that, okay? Oh, also stories would be part of imagery, IES. Oh, whatever. You know what I mean. Okay. All right. So there, first of all, we know that the brain loves stories. Second of all, we know that we are very visual creatures. Okay. So anytime that we can add pictures to new information, anytime that we can take information and we can tell a story that goes with it, or we can visualize it in our minds, we're going to remember the information better, okay? The guy who holds the record for memorizing digits after pi, I think his record is like a crazy number. It's something like, hold on, let me look it up. 83,431 decimal places after pi. Like, that's crazy ridiculous, okay? Anyways, he used imagery to try and remember all of these digits. So here's what he did. He like assigned like a vegetable or a fruit to every digit in our number system. So like the number 1 was like broccoli, the number 2 was like an apple, the number 3 was a banana, and 4 was kohlrabi, I don't know, whatever, okay? And so when he was thinking of the digits, he imagined a person sitting down eating the broccoli, which would have been number 1, eating the apple, number 2, and that helped him to remember the 83,000 digits after pi. So that's a pretty crazy reference. Let me show you another example of imagery, okay? All right, so from this right here, this is what a mathematician uses to remember a very complex formula. I don't know, it goes something like this. Whatever. It's a bunch of math. And then it's over like a bunch more math. Blah, blah, blah. Okay. All right. Anyways, so here's the imagery or the elaboration that he uses here. He says, Neiman came out. And Neiman is this name of this person. He's telling this story and he's using imagery to be able to do this. All right. So Neiman, okay, came out and jabbed at the ground with his cane. Bloop. You can like imagine like an old man jabbing at the ground and it would make like a little indent like the time sign, okay? And he looked up, bloop, 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 and he looked up at a tall tree which resembled the square root sign and thought to himself, no wonder this tree has withered and begun to expose its roots. Ha ha ha. Get it? Square root. After all, it was here when I built those 2 houses. D squared. The D squared would be like the 2 houses. Get it? Okay. Once again, he poked his cane times blah, blah, blah. You can read on here. Okay. So he basically created this whole big story so that he could remember this very complex equation. All right. Okay. Now, here's what we know. There's a hypothesis out there that says, ooh, duties. That says the more senses that we involve, the more likely we are to remember something. Here's the idea here, okay? If we can add pictures, if we can have you talk about the information that you're learning, if we can have you act it out using your body and touch and that sort of thing, all right? If we can have you smell it or taste it, okay? The more senses that we involve in an experience, the more likely people are to be able to remember that experience, okay? So I have a little test here. You want to get your paper out again. Okay, so I'm going to show you, remember you can always pause this to get your paper out. All right, I'm going to show you a list of, my brain is not working because it's almost 10 o'clock at night. I'm going to show you a list of words that have pictures that go with them, and you're also going to hear me say the words, all right? You may not write anything down until I get through the entire list. All right, here we go. Flag, basketball, road, flowers, beach, goat, cloud, explosion, mountain, queen. Go, right. Okay, you can go back through this video and you can check your answers, okay? And what you want to do is you want to see if you remembered more of those answers where we used sound and sight at the same time than when we did this list, the George Miller list with the snow, the chicken, and the crossbone, where you just had the visual without a picture and without me saying it. This time we added picture, the word, and of course the sound, okay? So sometimes this works and sometimes this doesn't. That's what this word hypothesis means, okay? In most instances and for most people, this helps them out tremendously to help store information more long term. All right, so here's what I want you to do with all this information that we learned about storage. If you remember, our essential question was, how do we store information? All right, so I'm asking you to reflect on what we've learned. Sally is failing AP Psychology. She comes to you for help. Explain four strategies to her that she can use to help improve her short-term memory for her retest. So what I want you to do is, at this point, I want you to go into Edmodo, all right? And if you look on Edmodo, if you look on Edmodo, I have a post up there, and it says exactly that, Sally's failing AP Psychology. I want you to go in there, oops, and I should log out and I should log in as Elmer the Elk. Hold on, so you can see this. Okay. Nope. Turn in. Click turn in. And right here, I want you to just type your response. One strategy, R-A-T-E-G-Y, that Sally could use is elaboration. ... And then you will explain how she can use elaboration. ... And then you'd move on to the next strategy, and then you'd press turn in assignment and tell me how awesome I am. All right, thus ends class for today. I will see you on Thursday if you have any questions, and I'll look through these and we'll decide if we can move on to retrieval or not. All right, awesome. Talk to you later. Have a good one.